I miss you guys so much, and I know you miss me too. But don't worry, this video is here for you, so you never miss a lesson, okay? Alright, you guys, so 4.3 right triangle trigonometry, September 22nd, 2016. And you guys, just remember this, okay? Right triangle trigonometry, because last lesson, 4.2, was circular trigonometry, right? So let's see, hopefully you can actually see the connection between them. They're same, but different, okay? So you guys, first page of notes, first of all, these notes right here, it should have been given to you by the sub. It's 4 pages, front, back. So make sure you guys follow along as you watch the video. Now, part 1 is sine, cosine, tangent, and the reciprocals. So again, SOHCAHTOA. So you guys, this is all review. So can you guys quickly stop the video really quick and fill in the blanks and do page 1 right now. Go! All right, welcome back. So you guys, here you go. Is this what you have? It's a Samshay. All right, it's all pretty much review on this page, right? We kind of went over it already last class. It's no different because we created right triangles within a circular trigonometry. In this case, we're only talking about right triangles, okay? All right, check your answers. Check it with each other as well. And you guys, let's move on to part 2. Actually, let's go on to examples. Let's go to this example here. Turn the page. All right. It says given number 17. Okay. Find 5 other trig functions of theta given this information. Cotard or cotangent of theta is 9/4. But you guys, there's a lot of different ways to calculate this. If you want to do it any way you like, that's fine. But I mean, I'm just going to do it this way just to keep consistent. But you guys, cotangent of theta is 9/4. But you guys, isn't tangent theta y/x? So we know, oh, this must be x/y, right? All right, because it's going to be whatever theta is, opposite of adjacent. And here it's going to be xy because it's going to be the reciprocal functions. Okay, so we've already got 1 out of the 5 that we need to find. There's many ways to do this, but I do know for sure that whatever this guy is, whatever theta is, right? I know that this guy is my x and this guy is my y, right? So think of it that way. And this guy is my radius, all right? So that means I know for sure that x squared plus y squared is going to equal my radius squared. Or I guess I can think of my hypotenuse squared because we're talking about right triangles here. Or hypotenuse squared, right? So we know it's going to be 9 squared plus 4 squared is going to equal r squared, which means square root of 97 is going to equal r. And that's our hypotenuse. That's our hypotenuse, okay? Because we're talking about right triangle trigonometry, okay? That's our hypotenuse, right? So you guys, let's do this now, okay? All right, so that means sine of theta is what? Oh, draw out your triangles, guys. Draw out your triangles. It looks like this, okay? Like this, okay? Now, what's our opposite of theta? It's going to be y/x. And what's our x? If you want, you guys, why don't you guys write out like x, this is our x, this is our y, right? So it's going to be 4/square root of 97, right? Because our opposite, okay? How about cosine of theta? It's going to be x over our hypotenuse, right? It's going to be 9/square root of 97. And our tangent we already have. So tangent of theta is going to be opposite over adjacent, which is going to be 4/9. And you guys, I won't do the or cosecant and secant theta because you know it's just a reciprocal of these guys here. All right? So make sure you understand that. Just think about the other ways you can attack it. You can attack it however you want to, okay? All right, let's move on. Oh, yeah. So I guess you can also think of it this way. This guy is our sine theta. This guy is our cosine theta, right? If you want to think of it that way. I mean, you know, okay, well, let's do that. You don't have to think of it that way. Okay. Okay? All right, sorry about that. All right, let's go back here. So now it says, use the given value. I'm going in order of the homework problems that you're going to see, okay? Sorry, I have to turn something off. So you guys, I'm going to go in the order of the homework. So let's try number 21. It says, use the given function values and the trig identities to find the indicated trig functions. Okay? So you're given cosecant theta is 3, secant theta is this. Okay? So now you're given some information. So what will you do with it is what you have to think about. Obviously, if cosecant of theta is 3, that means sine of theta is the reciprocal of that. That's an easy one. All right, cosine, that's an easy one because you know that secant is the reciprocal of cosine. That's going to be 4/3√2. Again, you can resimplify that or you don't have to, all right? Now, tangent, you know that's actually sine theta over cosine theta. So that means it's going to be 1/3 divided by 4 3 root 2. That's illegal to write. That is no. That means you have to simplify that for sure. Okay, so it's going to be root 2 over 4. Make sure you know how to simplify something like that. Okay, guys? You have to know how to simplify that. You can't leave that, okay? Just the way it is. So this is the solution right here. And you guys, this guy here, it says secant of 90 minus theta? What? What does that mean? So we're going to save that one and come back to it after we discuss the next few, okay? All right, so let's actually move on to part 2. Trig identities, complementary relationships. What? Don't worry, I'll explain it in this video. So you guys, Pythagorean identities, honestly, you don't have to memorize all 5 of these. It looks a little daunting, but you just have to really remember the first case, which is this. Sine squared x plus cosine squared x is equal to 1. Everything is derived from this guy, okay? So you just have to remember this guy forever. Sine squared x plus cosine squared x equals 1. Now, what happens if I subtract cosine squared x from both sides? We get this guy. That means sine squared x is equal to 1 minus cosine squared x. How about if I subtract sine squared x from both sides? Then I get cosine squared x equals 1 minus sine squared x. Alright? What about, now how do we get these two, the last two, right? The last two. Easy peasy. Alright? What happens if I take my original? I'm sorry, I'm going to choose x here, not theta, is equal to 1. What happens if I divide both of them by sine squared x? Okay? What happens if I multiply everything by sine squared x? Here's what happens. So I'm going to explain both of these cases. If I divide both of my sine, here I get 1. Cosine over sine, cosine squared over sine squared x is going to be cotangent x, right? And how about cotangent squared x? And how about this guy? 1 over sine squared x is going to be cosc squared x. I keep on wanting to write theta. Okay? That's why this guy came out. So if I take the original and I divide it by sine squared x to everything, how do you think we got this one? You are so clever, okay? You're right. We divided everything by cosine squared x, and that's how we ended up with this guy. So you see how all these are derivations of the original one. Sine squared x plus cosine squared x equals 1, all right? You're going to do some things with it later, okay? So we'll come back to those. Now let's go back to complementary relationships and acute triangles. So you guys, you know this. I mean, you can see this. Go ahead and read over these. You're like, okay? But I'm going to try to prove to you why these are true, all right? So you guys, take your classic triangle, your favorite right triangle. I know what it is. It's 3, 4, 5. Let's go 3, 4, 5, okay? And let's say this guy is my alpha, and this guy is called my beta, okay? You guys, what's sine of alpha? Isn't sine of alpha 3 over 5? Okay? But how else can I do that? Could I do how do I get the same value is what I'm saying, right? What is cosine of beta? Adjacent over hypotenuse. What? They're the same shape? What? You're right. It is the same thing. Because what do you know about alpha and beta? Again, I heard you. They're complementary angles, right? Complementary angles. And you remember what complementary angles are? They equal 90. Exactly. They add up to 90. So that's why, and that's why these guys produce the same thing. And that's what comes this. Sine of 90 minus theta is equal to cosine of theta. Think about our cosine beta, right? Our cosine beta, what about if I took 90 minus my beta? Don't I get alpha? And that's why sine 90 minus theta is equal to cosine theta. And all the rest of these guys work the same way. Okay? All right, so hopefully, another way to think about it is this. Another way to think about this. You guys, don't I have this guy here? What about if I call this guy theta? That means this coordinate, isn't it A, B? Okay? I can also think of it this way. Isn't there another, don't these numbers repeat somewhere else? And where does it repeat? It repeats somewhere like here. Right? It repeats somewhere like here. Isn't this guy also theta? And this coordinate is what? You're right. It's B, A. Think of it that way too. Alright? Alright, you can think of it multiple ways, and that's why these come about. Alright? Okay, let's go move back to up here now. Now it says here, D, secant of 90, so we're going to do D here. Secant of 90 minus theta, 90 degrees minus theta, what? Alright? What is that? Okay? Isn't this really essentially cosine of 90 degrees minus theta, if you think about it? Okay? I mean, you could cheat and look at this, but let's say you got really stuck. But 1 over cosine. But what's cosine of 90 minus theta? Isn't that the same thing as sine theta? And don't you know sine theta, which is 1/3? So that means 1 over that is going to be a 3. Okay? Try to watch the video again and listen to the explanation again. Secant of 90 minus theta, it's the same thing as 1 over cosine 90 minus theta because these are the same thing written different ways. And you know that cosine of 90 minus theta is going to be the reciprocal functions, right? Or complementary relationships, right? That's why it's 1 over sine theta and 3. They also call it cofunctions, okay, guys? All right, that's part 2. Let's try some examples. Okay, let's go here. That's part 2. Let's go to part 3. Let's do an example for part 2, okay? Now, you remember that classic sine squared theta plus cosine squared theta is equal to 1? You're going to use that now. This is actually a really important skill. It's going to come back to you again, okay? So you guys, this is a very important skill. Watch carefully because there's a specific way that we like for you guys to actually do this. So ready? Now, we have this left side and we have this right-hand side. So we call this left-hand side. We call this right-hand side, okay? You can start from whatever to achieve your goal. If you start from the right-hand side, you better end up with your left-hand side. If you start from your left-hand side, you better end up with your right-hand side. But I'm going to actually, you're going to have to, you'll have to play around with it a little bit. But I'm going to start with the left-hand side. And you have to state that. So I'm going to state the left-hand side over cosine theta plus cosine theta over sine theta. Okay? But my goal is this. This is my goal. Okay? All right. So let's keep going. Because remember, you have to watch for the goal as you do your processes. Well, I'm gonna try lots of different methods. Okay? You might not get it the first time, but it's all right. So sine and cosine. Okay, well, let's try to make these guys into one fraction. That means I'm going to multiply the top and the bottom by sine theta. Okay? Okay, I'm going to multiply these guys by cosine theta. You guys, I'm just getting LCD, right? I'm getting LCD. So what do you end up with? You end up with this. Sine squared theta, right? Plus cosine squared theta all over sine theta, cosine theta. Okay? You're essentially multiplying so then you get your LCD. All right, so now, oh my God, what did you see? What's sine squared theta plus cosine squared theta? You're right, it's 1. Remember that? That's why it's 1 over the denominator. So I'll write that at the bottom here. Okay? So it's going to be 1 over sine theta, cosine theta. But you're like, wait a minute. What's sine theta? 1 over. What's 1 over cosine theta? Oh, isn't that cosecant theta? Sorry. Isn't that cosecant theta and secant theta? Ding, 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 ding. You're done. And then you're done. Right-hand side. That's when you know you're done. And you have to say this equals the right-hand side, so it's equal to. You could actually make a full conclusion. Left-hand side is equal to right-hand side. Therefore, you're done. Okay? All right? But you guys, you have to start with the left-hand side. You have to actually write this, okay? And then the right-hand side, okay? Okay. So you guys, let's take a break. I know you're getting bored. Take a break.